Okay, so in this we're going to have a little view of some different types of angles and triangles and quadrilaterals, and we're going to look at doing some proofs about some of the rules that you'll mostly be already familiar with. So let's get started. So firstly, very basic, when you've got an angle less than 90 degrees, it's called an acute angle. We know, oops, that's meant to be a straight line. This is a right angle and it's 90 degrees. And this is 90 degrees. So whenever you see this little square bit, you know 90 degrees. And then we have angles greater than 90 degrees are obtuse. And then if we have, we're thinking about this part, so an angle greater than 180 degrees but less than 360 degrees. We call that a reflex angle. It's good to memorise these terms. The acute, so the right angled, which is probably the easiest, obtuse and reflex. Memorise these terms and what they mean. We all know what an equilateral triangle is. A little lat, try and spell it right. Triangle. This is when we've got all the sides and all the angles the same. So when you see this little line through them, you might in a question get a picture of a triangle with these lines through them. You know that each of these lines are the same length, which means all the angles are the same and all the angles are 60 degrees. And that's our equilateral triangle. And an isosceles triangle is when we have these two lines. Again, the notation is when you have that little dash through each of the lines. These two lines are the same length, but this line is a different length. And in this case, these angles are going to be the same, and this is going to be different. And so we then have a case where 2a, so a add a, or a times 2, plus b is going to equal 180 degrees, because in a triangle all the angles add up to 180 degrees. Which brings us on nicely to, I'm just going to draw a random triangle with angles A, angle B and angle C. And we know that A add B add C equals 180 degrees. Really important, need to know it, really basic, whether you're, whatever grade you're hoping to get in your IGCSE maths, you need to know this. Now, how would you prove that? How do we know that A add B add C equals 180 degrees? You could try and add all the different possible combinations of angles together, but that's going to take you a long time. Or we can think about it mathematically. Now let's just think about drawing a line up here. We'll draw that a bit better because we want it to just touch here, just touching this vertex, the vertex here of B. Now this line and this line are parallel. So what we've got now is, when we think about what we did previously with our angle. So we call this angle X and this angle Y. because this is a straight line, so x plus y plus b equals 180. We can see that, that's just, you can just see that there. If it's a straight line, it must be 180. Now we're going to apply what we've been learning about alternate and corresponding angles. So let's think A and X. I'm going to change the colour of my pen, so this will be more, actually I'm going to make a highlighter. And I'm going to change the colour of the highlighter just so we can see it better. Give it a nice yellow. So if we draw this, we can see that A and X are alternate. So A equals X, and we can see, and similarly also C and Y are alternate. So C equals Y. Now we know X add Y add B equals 180, but if we replace the Y and the X with A and C, we've got A add C add B equals 180, which is the same as up here. We've just proven that the angles of a triangle always add up to 180. Now, the next thing we're going to look at is, another little fact, which is just to memorise. So we're going to draw a triangle, but we're going to imagine this line here. So this line is going to be 180. So we've got angle A and angle B, and this, we don't know this angle, but we want to think about this angle X here. Okay? Because if we think about it, 180 minus A minus B would equal whatever this angle is here. We'll call it C. And we know that C plus X equals 180. So A plus B must equal X. Because if we were to take, I'll just show you why that is. So instead of having 180 here, let's make that C add X minus A minus B equals to C. So the C's are going to cancel, and X is going to be A plus B if we take the A over to the other side. So that's another nice little tool just to add, that if you want to know what this angle is outside of the triangle, you can add two other angles in the triangle together to give you that angle. And now we're going to think about quadrilateral. So a quadrilateral, remember, is just the generic term for any four-sided shape. So obviously a square is a quadrilateral, rectangle, a parallelogram. So any four-sided shape is going to be a quadrilateral. Now, with a quadrilateral, all the angles A plus B plus C plus D add up to 360 degrees. Now I'm going to call our sides of our quadrilateral P, S, R and Q. And I'm going to imagine that we draw a line through the middle of our quadrilateral. So what we've basically got is two triangles. So let's think about inside of each of these triangles. The total of the angles P, Q, R, S is equal to the sum of the angles in triangle P, S, R plus the sum of the triangles of P, R, Q. So we've got the angles of P, S, R. Their angles must equal 180, and then P, R, Q angles must equal 180, but the angles of P, Q, R, S must be these two put together, which is 180 plus 180, which is 360 degrees. So this rule here falls out of the fact that the angles of a triangle add up to 180. I hope that makes sense. Let's see some practical applications of these. So let's think of quadrilateral PQRS, and we're going to find value of x. So we've got P, no it's not a P, that's an R, P, Q, R, S, and we've got this angle is 78 degrees. We don't know angle X, we know this is 62 degrees, and we know this is 103 degrees. So we know that X plus 78 plus 62 plus 103 must equal 360, which is X plus 2, 4, 3, so equals 360, and therefore X must be 360, take away 2, 4, 3, which equals 117 degrees. That's a pretty simple, easy question. What you will often find is you'll often get something like this. So you've got angle here is 75 degrees. This angle here is 2x. This is x plus 50. And this is 3x minus 5. And we've got quadrilateral A, B, C, and D. And we want to find the value of x. Find value of x, and hence the values of all the angles. So what we would do is we're going to set up an equation. That is a terrible A, it's like a wee triangle. We know that each of these angles added together is going to give us 360, so let's just write that down. So we've got 75, add 2x, add x plus 50, add 3x minus 5. Now we're going to group like terms. So there's 2x, add x, add 3x, and that is going to give us 6x. And then we're going to take then that was 75, add 50, minus 5, and that's going to give us plus 120. Oops, sorry, that's equal to 360. Equals 360. Then we're going to deduct minus 120 from each side. So that's 6x equals 240. Divide both sides by 6. X is going to be 40 degrees. And if we, so angle A is going to be 2 times 40, which is 80 degrees. Angle B is going to be 40 add 50, which is going to be 90 degrees. Does not look 90 degrees for my terrible drawing. And angle C is going to be 3 times 40 minus 5, which is 115 degrees. So you see, this takes a wee bit more thinking, but is not, you're just applying some simple algebra that you've already done, and it always show as much working as you can so that you don't lose any points. And well, if you do silly arithmetic errors, you would lose a point, but if you've got all your working, it shows the marker that you've understood the concept and you know what you're doing, and those arithmetic errors will not be too terrible for you. So I hope that makes sense. Speak to you later.